Okay, diagnostic studies, just to bring you up to speed on what these things are. Basically, they are trying to figure out what's going. Well, there are two kinds of diagnostic studies, really. There are the kinds when a lake or another ecosystem isn't working quite right. You go out and diagnose, find out what's going wrong with it, and then the feasibility part of these is trying to figure out if it's feasible economically to put her back into shape and what it's going to take, and make some suggestions to the community and to the agencies involved on what can be done. The other kind of diagnostic study is if everything's going right, you can work on a system to try and figure out how to keep it that way. But the case here is Black Hawk's got some water quality problems, and so I just wanted to give you a sense here of what we did in this study, and that was we went out and measured a lot of things in the lake and in the watershed, and we're looking a lot at nutrients and phosphorus and the things, nutrients, mostly phosphorus, but also nitrogen and some other stuff out there to try and make a budget to see where things are coming from, budgeted nutrients and suspended solids, because those nutrients drive the quality of the water and the clarity of the water. And we look at transparency and a bunch of other things, lake productivity and condition, looking at chlorophyll, that's the green color in the water, algae, and the dreaded cyanobacteria and stuff like that. We look at sedimentation, deposition of sediments over the years, because we've got some really nice historical data. Then look for sort of watershed hotspots, trying to sort of, just like you do with any other budget, if you want to know how things are going, you want to project how things are going into the future, then you say, you know, where's the money coming from, where's it going? And then if you got, would it ever be that we'd have too much money piling up in the account? I don't think so, but that's kind of the case in the case here where we got too much nutrient. So you figure out how to stop it and where the places are that we need to work on, try to improve the water quality. We did a lot of monitoring, and this here you see the little lake up here. There's a big watershed. We call this the upper watershed, which is kind of funny because it's kind of down below in this picture, but it's down south. Upper watershed, bringing the water in. Pretty high watershed to the lake area ratio, which means that every acre in the lake has got a lot of water from the watershed contributing to it. Okay, so these are monitoring sites. We monitored around the edge of the lake, some places where water's coming in. We looked up in the watershed at various key points to see how things are moving. Okay, first off, let's look at water quality. Over here in the right-hand column, you kind of see the average of these measurements for all Iowa lakes, and over here you can see the averages for Black Hawk Lake. Secchi depth, this is the transparency. You want that to be a big number, and it's actually smaller than the average, so it's not real clear. This is these are in yards approximately. This is a meter is about a yard, and we use meters because it makes it real easy for us to do all the kinds of calculations we need to do. So that when you see a meter or a meter, just say it's a yard. These numbers, you don't care what the units are, but all we know is that's the average over there for Iowa. This is what we got in Black Hawk, and we want these to be low, and they tend to be real high. We've got a lot of phosphorus, and phosphorus is a good thing to have in the soil for growing plants. It's not a great thing to have in the lake because it grows too much plants. Suspended solids are high too, and that's a brown stuff, the various kind of sediment that's out there. It's about 50% higher than the average in the rest of in Iowa lakes in general. So it's a lot of stuff. We got water quality problems that have been exacerbated over time, high levels of nutrients, suspended solids, and low water clarity. And these are things that, of course, you and the community already know, but these are the kinds of numbers we need to do in order to budget it and figure out how to make it work. Okay, here's a temperature profile. I'm going to teach you how to read these funny-looking graphs. Okay, this is the depth here. This is the top of your lake, so you're looking like you're looking down in the water. This is time, and if the lines go straight up and down, then there's no stratification. It's sort of even all the way up and down. If the lines go side to side, then it's kind of stable or stratified. And this is temperature, and basically what you're seeing is all the lines are going straight up and down as we go through the season, and that means it's just not stratified. It's mixing from top to bottom. It's pretty shallow, so that's kind of a natural thing. Under ice in the wintertime, we get a little bit of stability because there's not a lot of energy coming in. But this graph down here just shows you that that's totally natural and normal. This is the effective length of lakes in general in the world, and Black Hawk's just right around this region here in length. It'd have to be something like 6 or 7 yards deep in order to really stratify. So it's just not anywhere near the kind of depth that it would take to be a stratified system. Stratification is important in a sense. like it's important to have a place to put your trash. You want to think of a basement. It's good to have a basement, you know, to put stuff in. Keep it there. It keeps out of circulation and stuff. And sometimes you can keep nutrients down in there and improve water quality that way. We just don't have that possibility here in Blacktop. It's just too shallow for that. But it would take a lot to get it deeper. Oxygen, got a lot of it out there, except right here that at certain times of the year that we don't see in these graphs, or certain years, you tend to get a loss of oxygen. You're going to hear about that in a little bit. Normally you have lots of oxygen. Those are big numbers. This is saturation, so if you see something bigger than 100, there's more oxygen than can stay actually in the water. And generally we see a lot of it, sometimes a little bit less. Generally it's pretty healthy environment for things to live in. But when you get a lot of, when you get the thing capped off for a long period of time, I guess under certain years, maybe like this one, you can have some problems. These are suspended solids, and just to remind you, the average is about 22. Same kind of graph, kind of mixed top to bottom, but periods of the year when you get tons and tons of the suspended solids, it flows in. We get some in rain events in the fall. We get it in the springtime when the water's flowing in, washing in that sediment for the watershed. Nutrients are big, lots of it. We get a lot of it in the fall, again with rain events. We get a lot of it in the springtime coming in, and generally fairly high concentrations of nitrogen. Sometimes we get tons of ammonia in there in the springtime and in the late winter. Lots of ammonia. Ammonia can be really, really toxic. Can be a problem for organisms. It can come in from the watershed. And can also come up from sediments on some occasions, but there's a lot of it in Blackhawk Lake, and that can cause some problems. Phosphorus. Lots of phosphorus out there, and again it's seasonal. Okay, here we have the early part of the summertime. You get a big spike in the spring when things are flowing in. It's kind of normal. Chlorophyll concentrations, that green stuff in the water, gets really, really high sometimes of the year, August, September, and you guys have seen this, I'm sure, if you've been out there, so it's a kind of a water quality issue. Cyanobacteria is what we used to call blue-green algae. These are the, I don't know, the plants that people love to hate. They smell bad, they form things called scum, you know, that's a technical term, and they can even be toxic under some circumstances. What we did is we looked at what was out there over the seasons that we studied it, and the light blue stuff here is blue-green algae or cyanobacteria. Is it a surprise to you? No, but there's really a lot of it, and they tend to be some of the kinds of things that can, under some circumstances, cause skin irritations and problems with pets drinking the water and stuff. So we measured things called microcystins. And these are the toxins that come out of cyanobacteria, and these are this is the distribution of the concentrations down here of microcystins that we found. This is the frequency of observations, and generally they're pretty low down in here. Usually if you're below about 20 on the scale, then people don't really consider that to be a problem. But about a quarter to a third of the measurements we made exceed those thresholds for what people normally think of as good for recreational water. So we're getting kind of too much cyanobacteria out there. So it's important in order to keep the value of the system, to keep those cyanobacteria from growing. Other kinds of bacteria, part of the job that we had was to measure bacteria as they move through the watershed and move into the lake. If you look into the lake, it had detectable E. coli. That's something that really isn't dangerous for you, but under most circumstances, but it's an indicator that you've got some fecal contamination. There's detectable E. coli most of the time, but fairly low concentrations in the open water of the lake, but quite a lot of the total coliforms, and that means just sort of all the stuff that lives inside the guts of animals. Tributaries have really high E. coli and total coliforms, and that's a concern, and it means, of course, that we've got either human or other warm-blooded animals contributing to the lake. Storm drains and tiles that we measured around the lake had quite a lot of it. A big number here would be 100, and you can see that those are all pretty big numbers that you're seeing there. So there's a lot of bacteria, a lot of cyanobacteria, the blue-green algae, a lot of those kind of bacteria that tell us that there is some either sewage or manure contamination coming